Thank you to the courageous few who have still managed to be here till the end. I'll keep it very brief, as short as possible, so that we can have more time for Annabelle and later on more time for questions. As we know, cybersecurity has gained global salience over the last 10 years. Again, cybersecurity means different things to different people, and in different countries the definition varies. But in essence, cybersecurity is talking about securing our critical national infrastructure from online attacks. And the reason why the definition of cybersecurity varies is because the definition of critical national infrastructure itself varies from country to country. So for example, countries like UK have a very specific number of CNI. So UK has 11 sectors which they define as critical national infrastructure. But that definition is very loose in many other countries. Just spend a minute on why we are talking about cybersecurity today, why we were not talking about it in the 1980s. Compare that to the banking industry, which has been the front runner when it comes to adopting security technologies. To understand that, we just need to spend a minute looking at how these systems have evolved. For the sake of this discussion, we will be specifically talking about cybersecurity in the context of industrial control systems, and more specifically in the electricity infrastructure. We will not be talking about the other areas. So if you see in this particular sector, the way the systems have evolved is initially we had very isolated devices. They were in a small corner. They were doing their own work, hardly any connectivity with anything else. And then over a period of Darwinian evolution, these isolated devices, they start getting connected for point-to-point interconnections. And then the next phase is where they start evolving into a small network. People still believe that they are secure because the way in which these devices talk to each other, the communication protocols basically were very much proprietary. And security by obscurity was a very much understood concept. That works fine till a certain level, but beyond a certain point, security by obscurity basically fails. And today we are talking about interconnected systems, distributed systems, and this has typically been initiated somewhere in the mid-90s, where utilities started adopting commercial off-the-shelf technologies, standard IP-based communication. And this happened primarily for two reasons. Firstly, it was because there was more and more automation, and it was very easy to leverage off-the-shelf technologies for better industrial automation. The other reason, of course, was cost. Maintaining proprietary networks is hugely expensive, and to use these off-the-shelf technologies gave the utilities orders of magnitudes of saving. And today what we are seeing is that when we talk about interconnected systems and then into the realm of distributed systems, where we have a lot of software involved, where we have a lot of communication involved, then cybersecurity really becomes a challenge. Another very short slide on why we need to see it in a slightly different context from IT security. At the beginning itself, I would say that the basic principles of IT security, they can very much be applied. But the design philosophy, the philosophy of defense, is slightly different. Because the way in which IT looks into security and the way in which industrial systems look into security are slightly different. And they are different because of the things that these two different systems do. So I mentioned banking. Now, banking was one of the first mainstream industries that brought cryptography into mainstream. The primary purpose there is, again, securing the data, primarily talking about confidentiality aspects. On the other hand, when you talk about industrial systems, we are not so much concerned about the confidentiality aspect of the data, but we are more concerned about the availability of a physical process. Sometimes if your laptop gets hanged, all you need to do is to press the big red button for a few minutes, and it reboots. Some magic happens at the back end, and more often than not, it resets itself. You cannot have the same philosophy for an industrial system. When we're talking about 5 nines of availability, that the system has to be up for 99.999% time, which basically means less than 6 minutes of downtime per year, rebooting doesn't really work. And then you see the problem. Now, Microsoft releases a patch every second Tuesday of the month. A lot of these patches have security elements. To install that patch on a normal IT enterprise system, you basically need to reboot. But you cannot simply dump that philosophy onto an industrial system. So that is what I mean when I say you can still use principles of IT security, but the philosophy of defense is fundamentally different in IT systems as compared to the industrial systems. For a long time, I will again keep it very brief, for a long time people actually believed that these industrial systems were completely isolated from the internet, and because of this isolation, they were completely secure. But as the most recent and the biggest attack has shown, Stuxnet, that the attacks may not always be outside in, but they can also be inside out. So while perimeter security is a good starting point, it is definitely not the end. We need to build security right from inside out. A year back when I was still studying, I was doing my PhD, and one of my colleagues and friend, Aaron Leverett, he was doing his master's. So whenever we discuss with the customer, utilities, industrial customers, they used to say that our systems are completely isolated. We have a very well-managed demilitarized zone, DMZ. So we initiated this project, and what we tried to do here is to find out whether we can actually locate control system devices directly on the internet. Has anyone heard of this search engine called Shodan? Anybody? Of course. So this is a very simple search engine like Google. You just put a query, it gives you certain results, but you have to choose your query very intelligently. So the query is basically an element which appears in the HTTP banner of a particular product. And when you put it there, it gives you the IP addresses of all the devices that are online at that point of time. So we did this experiment for about 4 or 5 months. We built up a historical database. We mapped on these IPs to the actual location on the surface of the Earth through geolocation APIs and using the timeline APIs. So the other thing that you could do is to have a look at that system and then query some exploit databases like Metasploit, and then try and make an educated guess as to which of those exploits might work on this device. In these 6 months, we were able to identify and pinpoint more than 10,000 devices. Many of them, actually a significant chunk of these devices were actually being used for critical national infrastructure. We contacted various certs, and through those certs, we have tried to convince these owners that they should put these devices offline. So a lot of work, especially my colleague Aaron Leverett, he also gave this talk at Black Hat this year. So he's really been active there. Here is another screenshot from a wonderful researcher, Travis Goodspeed. This is the output of a random number generator. And a random number generator, by definition, the output should be random. Now, as you can see on the screen, the output is not very random. And this random number generator is basically the base on which your entire security properties are built on. So I'm just trying to say that the current state of security is not a very optimistic scenario. And from this present, we are talking about reaching here. Annabelle will talk more about this diagram. This has become famous as the spaghetti diagram. Here you have more than 24 principles talking to each other. And of course, all these principles need to talk to each other in a very secure way. Reaching from the first position to the second position is going to be an extremely challenging task. My final slide, how do we start? Well, I think the starting point can be a security roadmap for utilities. There are various international standards which are currently working on this. I've taken this from ISA 99, where they talk about cybersecurity management system. And again, it has various components, right from personal training, awareness, to doing vulnerability assessments, doing risk management in their entire system, and thereby building up a complete cybersecurity roadmap. So I'll stop there and I'll let Annabelle take over. Thank you.